Hello everyone! In the previous video, we successfully built a WireGuard VPN server on Windows, and our client was able to establish a secure VPN connection to the server. However, with the default full tunnel configuration, many of you may experience this issue. The VPN connection is working, and the WireGuard server responds normally. But as soon as you try to access the internet, for example by pinging Google, the connection fails. In this video, I'll show you a more practical approach for most home and small office environments by configuring a split tunnel. To solve this problem, we'll use a split tunnel configuration. Specifically, we'll route traffic in two different ways. All regular internet traffic, such as web browsing, YouTube, or online services, will continue to use the client's local internet connection. Meanwhile, only the traffic destined for the WireGuard server and your home network will be sent through the VPN tunnel. This approach not only keeps your internet connection fast, but also allows you to securely access your internal network whenever you need. Now, on the client, deactivate the VPN connection. Then click Edit to modify the WireGuard configuration file. Under the Allowed IP setting, remove the default configuration. Then specify the WireGuard server's VPN IP address, followed by your local LAN subnet. Once you've finished making the changes, click Save to save the configuration file. Now, reactivate the VPN connection by clicking Activate. Now, ping the WireGuard server and Google's DNS server once again. As you can see, the client can still reach the WireGuard server, while internet access is restored through the client's local network. This confirms that our split tunnel configuration is working correctly. However, at this point, your VPN client still won't be able to access other devices on your local network, such as your NAS, or establish a remote desktop connection to another computer in the LAN. Before we continue, let's verify the current status. Try pinging any device on your local network, such as your NAS, another computer, or even your router. As you can see, the request times out, which means the VPN client still can't communicate with devices on the LAN. To resolve this issue, go back to your router's management interface. We'll need to add a static route so that devices on your local network know how to reach the VPN clients. The steps for configuring a static route may vary depending on your router model. Simply look for a menu called Static Route, Routing, or Static Routing. Once you've found it, create a new static route entry using the following settings. For the destination network, enter the VPN subnet used by your WireGuard network. In this example, we'll use 10.10.10.0. For the subnet mask, select 24. For the gateway, enter the LAN IP address of your WireGuard server. This is the IP address that will forward traffic between your local network and the VPN clients. Next, under the interface setting, select your LAN interface. This tells the router which network the static route should be applied to. For the metric value, simply leave it at the default setting, or set it to 10 if required by your router. Finally, enable the static route, then click Save to apply the changes. Now, let's switch back to the client and verify that everything is working correctly. As you can see, we can now successfully ping devices on our local network. This confirms that the static route has been configured correctly, and our VPN client can now communicate with devices inside the LAN. And that's it! In this video, we've successfully configured WireGuard Split Tunnel. I hope you found this video helpful. If you did, don't forget to like, subscribe, and turn on the notification bell so you won't miss any upcoming tutorials. Thank you for watching, and I'll see you in the next video.